All right, so we have now the thalamus. Okay, let's draw it properly. All right, so that's the thalamus. That is shaped like a what? The thalamus is shaped like a what? An egg. Reasonable? It is egg shaped. All right, so this is a, what type of section am I doing here now? A sagittal. Okay, so this is the thalamus right here. And then in relation to it now is the what? The caudate nucleus. Okay, so the caudate nucleus has a head, right, which bulges forward like that, right, and then will become a body. Okay, so it will become a body, which will then swing down around to become the what? The tail. Reasonable? Alright. Now we leave like that and then now end as the what? The tail of the caudate nucleus. Alright? Alright, so we can sort of, something with WJC? Mr. Chin?
David is checking on it too. Let me check with him.
Okay. Alright, so this is the, as I said, the head. Then the head lies what? Anterior to the what? To the thalamus. Reasonable? And then that's going to be continuous now with the, so we come here, and everything which is going anterior to this is the what? The head of the caudate nucleus. But once we start to do business with the thalamus, you become now the what? The body. And then now you will leave and become the what? The tail. Reasonable? In this groove, alright, and the tail of the caudate nucleus ends in what structure, Shamara? The amygdala. Okay? There is no really connections per se, but this is going to end in the amygdala. Alright? So this is going to end here in the amygdala. Then we can now put the what? The lateral ventricle. Okay? So the lateral ventricle will have a what? An anterior horn. It will come around and have a what? A posterior horn. And then it will have a what? An inferior horn. Okay? So we can then put them in the what? The lateral ventricle. Okay? Now what structure will floor the lateral ventricle? What structure floors the lateral ventricle? What's the structure that's going to floor the lateral ventricle? What structure will floor the lateral ventricle? What structure is going to floor it? So what structure is going to floor the lateral ventricle? What's the structure that floors this? Let me look on this one diagram here. Give it a chance, bring it on. There. No? There. Okay, so the structure that we see in the floor of the lateral ventricle is the what? The hippocampus. Isn't that so? So you see the hippocampus, right, Shamara? Then laterally, Shamara, we see a little bump. What is that little bump there? And Dr. Lidinque and them were pointed collateral eminence. Okay, so we see the hippocampus here, and we see the, and then that hippocampus is covered by what structure? What's the structure that's going to cover the hippocampus? The alveolus, right? And then it's going to converge medially to form a structure known as the what? The fimbria. Fimbria of what? The fornix. Okay? So the fimbria of the fornix. The fimbria will continue as what? The fimbria, once it takes off, once the fornix takes off from the hippocampus, it becomes what? So once the fimbria leaves, like a plane taking off a runway and just zoom up in the sky. But when it takes off, what is it known as? Crura. The crura, reasonable? Which is going to swing around, just inferior to the what? Splenium of the corpus callosum, where there are some commissural fibers. Greetings, David, how are we going? Very good. Then it's going to have the body of the fornix, reasonable? And then excellent, 300 marks. And then we'll descend as the what? Anterior columns, reasonable? And the anterior columns will divide into some pre-commissural fibers and some post-commissural fibers. Alright, so there you can see the hippocampus. This is something called parahippocampal gyrus. Parahippocampal gyrus. And you just put in the head now that there are two connections there between the hippocampus and the parahippocampal gyrus, two main highways from here to there. And the two main highways are 1, perforant pathway, and 2, alveolar pathway. So there are 2 pathways from the entorhinal cortex to the hippocampus. One is called alveolar, and the other one is called perforant. Okay? So two pathways connecting, the perforant pathway and the alveolar pathway. Okay? So from the sensory association cortex, you're understanding what I'm saying. You're looking at the paper that you're writing, and you know the exact words you're writing, you know where you are, everything, So all from the sensory association cortex goes to the entorhinal cortex, right? Okay, and from the parahippocampal gyrus, then to the hippocampus. And the 2 pathways are the perforant and the alveolar pathway. Okay? Okay? So there we see the hippocampus, and then from that alveolus now we find a lot of efferents leaving to form a band, a ribbon, which is known as the fimbriae of the fornix. Fimbriae of the fornix is just on the medial aspect of the hippocampus, like a jet taxiing down on airway runway, and then it takes off. And as it takes off, it flattens off like the wings of a plane to become the what? The crura of the fornix. Right? And they fly up right under the what? The splenium of the corpus callosum. There's some hippocampal commissure there, reasonable, and then now continues as the body. And then now as it is continuing forward now, it starts to descend. And as it descends, it's held up by a curtain. And that curtain is known as what? The septum pellucidum. The what? Septum pellucidum. It then dives. Right, downwards as the anterior column of the fornix, reasonable, just anterior to a thing called the what? Interventricular foramen of Monro. The interventricular foramen of Monro dividing into precommissural fibers going primarily to the septal area and then down into the hypothalamus as the what? The end in the mammillary body. Okay? So that's the story there. But remember, the fornix has 3 things about it. 1, it is primarily a projection fiber system. Reasonable. 2, it's connecting the hippocampus primarily to the mammillary body. Right? And then very important to know that it has what? Reciprocal fibers. Okay? So in the brain, everything is what? Tends to be reciprocally connected. If I send messages to you, you'll send messages back to me. Right? The only fellow who doesn't really follow that rule of law to a great deal is the amygdala. So the amygdala is a fellow that he is not under great control of the cortex. He will send a lot of information up, but very little will, there's not great input back to the amygdala. Okay? Alright, so there we can see that. So there we can see now that in this roof, so you'll see here that the floor of the what? The floor of the inferior horn of the lateral ventricle is formed by what? The hippocampal gyrus, by the hippocampus. Reasonable? Right? So we must differentiate between hippocampus and hippocampal formation. Hippocampal formation will include other things. Reasonable? Alright? And then now we can put in things like the stria terminalis. Okay, where's my red here? So the stria terminalis is coming from where? The septal area, isn't that so? And then traveling where? In the groove, isn't that so? Between the what? The thalamus and the caudate nucleus, and then it's going to be to the what? To the amygdala. Reasonable? Alright, so we find that in the roof of the inferior horn, we'll find the tail of the caudate nucleus, right? And the stria terminalis and a vein. What is the name of that vein? Thalamus striate vein. So traveling along here now will also be the what? The thalamus striate vein. Alright, so the thalamus striate vein will also be along in this area here. Reasonable? You find the thalamus striate vein. Alright, comes around. Okay, so you can see, okay, then now, if this is all in here is the lateral ventricle, then we have to put the what? The corpus callosum. So the corpus callosum comes around like this, like that, has a big what? Splenium, isn't that so? That's the corpus callosum that comes around, right? So that's the what? That's the, then it's going to have a what? A genu, reasonable? That's the genu of the corpus callosum. And then it is going to attenuate to form the what? The rostrum, reasonable? So the rostrum, which is then going to become now the what? The lamina terminalis, reasonable? That's going to become the lamina terminalis. So this structure is very important, and this is the corpus callosum. Okay? Now in more primitive animals, the corpus callosum is not that very well developed, right? In some maybe, and then now we have what is really very well developed is the what? The anterior commissure. Reasonable? But in higher animals, now the what? The corpus callosum is a big boy. Reasonable? Then we have the what? The fornix. So from the hippocampal giants, from the fimbria, very good. All right, so then we're going to have this coming off right here. Okay, very good. And then there is a crura of the fornix. Thank you, Mr. Chin. There's a crura of the fornix. It's underlined right here. That's the body of the fornix now. That's underlined right here. And then now coming to what? To deep down. Isn't that so? That's the fornix. Meeting the what? The anterior commissure. Meeting the anterior commissure, and then going to divide into what? Pre and post commissural fibers. I shall just put this a little further up. Okay, this head of the caudate nucleus is a little down, but at least it's showing you a little what is happening. Then all of that is going to be attached to what? To the what? To the septum pellucidum. Okay, so that's the septum pellucidum. Okay, the septum pellucidum line right here. Okay, so these are some of the relations. This is the interthalamic adhesion right here. Okay, there is the foramen of Monroe right here. Okay, so the foramen of Monroe right about here. Okay, so say you were to put a little man, you could put a little man to stand up in here. Reasonable? And you could put a little man to stand up in here. Very good. Reasonable? So we see now that when you're in the inferior horn of the lateral ventricle, when you're standing in the inferior horn of the lateral ventricle, the roof is formed by the tail of the caudate nucleus and the stria terminalis, but is floored by the what? The fornix, which is now going to be covered by the, very good, it's going to be covered by the what? The what? Covered by the alveolus and by ependymum. And then just on its medial side will be the what? The fimbria. Alright? So, and then now, when we're standing in the body of the lateral ventricle, what will the floor of the body of the lateral ventricle will be formed by? Remember, by the way, there's this magical structure that is going to be, let's use another color. Alright, so there's this magical structure that is coming from here and going back just at the medial border. What's that magical structure here? The stria medullaris thalami. Reasonable? So that's the stria medullaris thalami. Okay? So when you're standing on the floor, so we're going to look at it a little later. Okay, we just hold that for me. When you're standing in the lateral ventricle, on the floor, there's a thalamus like that. Reasonable? Overlaid laterally by what? What structure is overlaid laterally? The body of the caudate nucleus, isn't that so? So the body of the caudate nucleus is overlying it laterally. Okay. And then in here will be the what? The stria terminalis. There. And the thalamus striate vein here. Reasonable? Then we find right on this medial border here will be the what? Stria medullaris thalami. This is the floor of the body of the lateral ventricle. Isn't that so? So there we can see now this is the stria medullaris thalami here. So stria medullaris thalami. And then on the roof, on the fornix, the superior surface of the thalamus is something called what? Tila what? Choroidea. Isn't that so? telocoroidea will be right here. And then now, the interventricular foramen of Monroe is right there. Reasonable? And anterior to the interventricular foramen of Monroe is the what? The anterior column of the fornix. So we're looking down on the superior surface of the thalamus. Reasonable? And then now, the structure that is arching over the thalamus right here is the what? The whole fornix. Isn't that so? So the fornix is just arching over it as a superior relation. So these are all some important relations here. Okay, so very important, okay, is remember, so this is a horizontal section. So there's a lady here, is her name Akila? Do you have a student named Akila, yes or no? Am I saying the name right? Where's Akila? Where is she? Very good. Very good. Sitting near Dr. Brownie. Isn't that so? Very good. Yes. All right. So we see here now, this is a horizontal section. Watch here like this. Okay. So Akila was asking me yesterday about a little about the internal capsule. So Akila, look here. All right. So let's look at. We see this whole thing like a crown up here. What is that whole crown called? See, it's the corona radiata. We see what that crown is known as what? The corona radiata. Okay, the crown is called the corona radiata. Okay, we're looking for another section here. Let's look at this one. Okay, I'm trying to see one that I can see some. Give a chance. Give a chance. We really have to get some new fresh brains. Okay? But if you look here, Akila, you see right here? Right here? So there is an internal capsule, right? And it is now what? Spreading out to form the what? The corona radiata. Okay? So the internal capsule is really compressed what? Ascending and descending fibers. Fibers that are going primarily to the cortex and are coming from the cortex. Before we go to the cortex, we need to do what? Synapse in the thalamus. So different nuclei of the thalamus project to different areas of the cortex. So the internal capsule is really just a lot of cars going up and a lot of cars going down. So a lot of traffic. Reasonably, there's a lot of traffic going everything, but it is now compressed. As it is passing through the core of the diencephalon, it is now going to be compressed, the internal capsule, by laterally what? The lentiform nucleus. And the lentiform nucleus is going to be formed by the what? The globus pallidus. Reasonable? And we have a Professor Labutin is going to deal with it tomorrow or the next day, and there will be a GPI and a GPE. Reasonable? External to that will be the what? The putamen. Alright, so that's the putamen right here. Okay, just relax. This is the putamen right here. Okay. Anteriorly, here is the what? Head of the caudate nucleus. Anteriorly, that's the head of the caudate nucleus here. And posteriorly will be the what? The thalamus. Isn't that so? Some other color. Purple. Right? So posteriorly here will be the what? The thalamus. Okay? Alright, so Aquila. There we're looking at a horizontal section identical to this. See right here? Okay? So, very good. So there we can see the thalamus right here. Very good. That's the head of the caudate nucleus. And over here we can see the lentiform nucleus. And then intervening at this L-shaped band is known as what? The internal capsule. This is a horizontal section of the internal capsule. So the internal capsule is the most important projection fiber system in the brain. Reasonable? The most important. And we said it composes of what? How many parts to it? 3 parts. So we have an anterior limb, we have a genu, and we have a posterior limb. But this posterior limb is subdivided into how many parts? Shamara. How many parts is the posterior limb subdivided into? So we have an anterior limb, a genu, and a posterior limb, right? And then now, the posterior limb is subdivided into 3 parts. One part is the part that is between the what? The thalamus and the lentiform nucleus, and that part is going to be known as the lenticulo-thalamic part. Reasonable? Then there is going to be a part that will what? Continue on beyond the thalamus. Okay? It's continuing beyond the lentiform nucleus, posteriorly, and that part is going to be known as the retro-lentiform part. Reasonable? So we have a lenticulo-thalamic part, then we have a retrolentiform part. Now the retrolentiform part is, and I will show it, this is one of the most important things to know. The retrolentiform part is going to pick up from the LGB, and is going to be primarily a conduit for the LGB, for the fibers leaving the LGB. So sometimes we say retrolentiform part is synonymous with optic radiation, right? But that retrolentiform part contains many other things. But because the visual pathway is so important, retrolentiform part is just now christened and dubbed the what? The optic radiation. Okay? But it is the retrolentiform part. Really contains the what? The optic radiation. So another thing for the optic radiation is known as the geniculocalcarine pathway. But very important, remember the internal capsule is ascending tracts and descending tracts. So this is going to be going to where? To the occipital, to the visual cortex. So from that area now, we're going to have fibers that are descending back to the what? To the pons. So there's also going to have in it occipitopontine fibers, right? So that retrolentiform part is going to also contain occipitopontine fibers. Okay, that are very important. So Dr. Ledenquist will be lecturing you tomorrow, right, Patrick? On the cerebellum, right? He's going to be lecturing you on the what? The cerebellum. And he's going to be talking about synergy of movement, okay? And then he's going to be pointing out that from nearly all areas of the cortex, the cerebellum is going to be receiving a lot of input, so that we can have what? This highly coordinated movement occurring very quickly and very fast, right? So the visual input is very important going to the cerebellum. Reasonable? So the retrolentiform. And then the third part of the posterior limb is known as the sublentiform. And that sublentiform part is going to be dipping down below, and that sublentiform part is going to be carrying mainly fibers from the MGB, right? And that's going to be carrying all the auditory radiation. Reasonable? So you're going to find the auditory radiation. The auditory radiation is going to be coming from the thalamus and looping in the temporal lobe here, and then feeding up to which gyrus? Heschel's gyrus. Isn't that so? So from MGB, we're going to go via the auditory radiation in the sublentiform part of the internal capsule, feeding onto Heschel's gyrus, the middle of the superior temporal gyrus. Okay? So the internal capsule, very important, having 3 parts: an anterior limb, a genu, and a posterior limb. So it is the main highway in the brain. So nearly all of these important tracts. So in the anterior limb, let's just look at ascending fibers. Where do we think we'll find ascending fibers from in the anterior limb? So anterior limb is going to be taking us primarily to where? Especially to the prefrontal area, isn't that so? It takes us to the prefrontal area, and it also takes us up to the cingulate gyrus. So therefore, you will tell me that it's primarily from when we look a little later at the dorsomedial nucleus. Isn't that so? So the anterior limb is basically going to be taken from the anterior nucleus and the dorsomedial nucleus. Okay, so that anterior limb. All right, so my wife just had a very interesting case. In fact, I asked just for a little copy of the thing. Very interesting, the CT report of it. All right, I just put it up before I came. All right, and that person was a patient and just coming, not aware of himself again. Was a good patient, always on the ball, and no longer aware of himself. And the daughter has to be coming and not aware. So she was really always like to discuss things with me, because I taught her how very good. And she loves her neurology. So we discussed it. And then now, so the CT showed now that she has vascular dementia, right? So what's happened? She had a cerebrovascular accident in the anterior limb of the internal capsule, okay? So it's specific, so therefore shutting down a lot of the input to the what? So a lot of the traffic that will go from the to the prefrontal cortex, because the only way you can get there is through the anterior limb of the internal capsule. So if you get a cerebrovascular accident there, then you're going to be what? Cutting down the amount of what? Connections with it. Reasonable? All right. That's called, you're going to see a whole thing of what's called vascular dementia. Reasonable? All right. Then now, so that's very important. It will also have descending fibers. Reasonable? So you're going to have thalamocortical fibers from the thalamus, and then descending fibers. Then in the genu of the internal capsule, we said the genu is the most important part. Very, very important. Well, one very important part, because it will contain the corticobulbar, and also from VA and VL. Right? So you're going to affect now VA and VL. And already we know that VA is equal to what? Basal ganglia input, and VL is equal to what? Neocerebellar input. And this VA and VL are going to where? Three destinations: motor, premotor, and supplementary motor cortex. Reasonable? All right. Then in the posterior limb of the internal capsule, we have the most important tract, and that is the pyramidal pathway. All right, the pyramidal pathway. And the way the man is laid out is that his neck is about right here, and then his foot is right down here. Reasonable? So we're going to have the corticospinal tract. Very important is the cortico-rubral pathway is also going to be there. Reasonable? Then we're going to have, then we're going to have important thalamocortical projections. From which nuclei of the thalamus we expect? From which nuclei of the thalamus are we expecting? So VPL, isn't that so? Very good. VPL, VPM going to the what? The post-central gyrus. Isn't that so? VPL, VPM. So, as I said, this internal capsule, which is sandwiched. So if we look at a frontal section through the brain, two last very quick drawings. So two things you must be able to find in the exam. When you look in the exam at a section of the brain, like this is going to be the internal capsule here. That's the internal capsule here. If you're looking at a very anterior section, you're going to see one gray mass on the medial side of the internal capsule. If you're looking at a very anterior section, you're going to see what? One gray mass on the medial side of the internal capsule, and that is going to become confluent with what? And blend with the putamen. Reasonable? So this is how it's going to look. So this is a very section like we're looking at here. So this one right here. There's the thing right there. Okay, so there. See it right here? So we see now that there is the internal capsule right here. And then we see now the head of the caudate nucleus becoming confluent with the putamen. So we see there's just one gray mass on the medial side. Okay? And this area where it becomes continuous, this area down here is known as the what? The ventral striatum. Okay? And in that area, you find a very important nucleus. And what is that nucleus called? Nucleus accumbens. The nucleus accumbens, right? So you have a lecturer by the name of Dr. Lorian Young, yes or no? Do you know Dr. Lorianne Young? Yes or no? Young Martin. You know her? Yes or no? You have been exposed to her? Very good. Okay. So her area where she did her doctorate on is that area right here. So she did her work on the nucleus accumbens. And who was her supervisor?
You.
No. Me and the man as hell. Her supervisor was what? Professor Young. So Professor Young, who comes to lecture you? Very good. So Prof Young was her supervisor, right? So Prof Young was, in fact, maybe one of the very first papers I ever did. Well, the first paper I did was with Professor Thay on the breast, looking at sodium nitrite. And we presented that at the 100th Congress in Washington at the Anatomical Association. That's the first thing we did, because I did some electron microscopy. But the next two papers that were very exciting were with Professor Young. So we looked at chloroquine and acetylcholinesterase levels in the spinal cord. Reasonable? So Prof Young, so when I came to university, he was my lecturer. In what year? 74. Reasonable. So, and Prof Young, you'd say, still looks young. Does it look young? Very good. All right. So when I came here, he had just returned from Scotland. Right? Right. So, isn't that interesting? But he was a very good lecturer. And then when I went to anatomy, then he was the professor of physiology. Right. But he was so brilliant with it. And we did a lot of exciting work with patch clamp techniques and impaling cells and looking at doing a piece of big what, man, for his oscilloscope and all that kind of things. Leave it alone. But my first two, that's why I have a great respect for him. Right? So he's a brilliant researcher. They made him pro-vice chancellor for research at the university. All right. But he was Prof. Who is it? Dr. Lorianne Young Martin, right? And I know she has the greatest regard for him, right, JP? Very good. All right. Very good. So that area is known as the what? The nucleus accumbens, or in the area of the ventral striatum. Important in what? Do you know anything about it? Important in what? Important in what? Very important in drug addiction. Reasonable? Drug addiction and in reward. Okay? So when people die of cocaine, you know these people die of cocaine and all of that, and they look at that area there, it stains what? Very intensely. Okay? So okay. Give it a look. But I had to give you a little what? History. Alright? Alright, very good. So as I said, if you see one grain mass on the medial part, that is what? Okay. Now give a chance. There we see now the internal capsule again. Reasonable? In a section like, let's just pick up any section. Okay, what about this section here? Let's look at this, it's a nice one. What do we notice right here? So, chin, we want to really get hard on this area. Okay? Hard on it. Very good.
Yeah, it's on the
good.
Yes.
Is that a good way to
From
take it?
Sunday
So there you can see, and that's why they call the word striatum. Reasonable, we see the what? The striate appearance. So anteriorly and inferiorly, the two are continuous. Okay, the anteriorly and inferiorly, the putamen is now going to be continuous with the what? With the head of the caudate nucleus. However, when we take up, let's look for another section. Alright, I'm going to try and find out a nice section to show you. Give it a chance. Let's see a nice section. See, that's why sometimes when you come, you have to what? Put out all these things. There. Okay, so when we look at this section right here, watch here, there we will see the what? The internal capsule right here. And that's the internal capsule. And how many grain masses do we see on the medial side? 2. Right? This one is going to now be the what? The thalamus, and this boy up here will be what? The body of the caudate nucleus. Reasonable? So we're going to see 2. So this head of the caudate nucleus, which is here, head of caudate nucleus, right? Blue is what? The putamen. Sorry. Blue is the putamen right here. Right? So on this section here now, we're going to see the thalamus coming in. You can hold that. Yeah. The thalamus is here. There. The thalamus becomes very big. Alright? The thalamus is there. Okay? And then now the caudate nucleus becomes just this little guy over right here, and he becomes now the what? The body of the caudate nucleus. Then the grey mass at the other side we see now is what? At the other side now we see what? Lentiform nucleus, which is going to have what? The globus pallidus medially, and the laterally will be the what? The putamen. Okay? So what we see, and the sections, you're going to get a lot of these brain sections here. So critical is this. Look at how many grey masses you see on the medial side. This one has 2 grey masses. This one has 1 grey mass. Reasonable? And this guy up here is called the what? The body of the caudate nucleus. And where you see the body of the caudate nucleus, you're going to also generally see the tail, because you're going to be in now the inferior horn of the lateral ventricle. So that's hippocampus here. Reasonable? So this is the space right here. This is the inferior horn of the lateral ventricle. And then in here we're going to find the what? The tail of the caudate nucleus. Reasonable? The tail of the caudate nucleus, and medial to the tail of the caudate nucleus, who do we find? The stria terminalis. So the stria terminalis is here, stria terminalis is there. You see it? Medial to it. So this is going to be body of caudate nucleus. This is going to be stria terminalis. And when we look in the roof of the inferior horn, we see tail of caudate nucleus and stria terminalis. Reasonable? And then traveling, as I said, in the middle there, that's not really great consequence to us right now, is what? The thalamostriate vein. Okay? That's very important. Okay, so the sections. So we should be able to identify the sections. So Dr. Ledenko is telling him that we must what? Look at the sections. Okay? So let's just spend about 10 minutes and look at some sections. So we're just going to take up some arbitrary sections. Reasonable? Or we just take up some arbitrary sections. Okay? Just one at a time. I'll just take up some arbitrary ones. Pretend we're in the exam. Okay? So let's just take up this one. This is very nice. Okay? So let's one second. So very interesting. Is all of this thing on what? Sodium nitrite. So you ladies you're a lot of ladies in here, reasonable? And now they're just starting to ban the use of sodium nitrite as a preservative in America. But way back like in about 93, or I can't remember what year we did the people. Right? So we took some rats and we gave them, in their drinking water, we gave them what? Sodium nitrite. And then just let the pregnant mothers have the sodium nitrite. Then these pregnant mothers brought forth litter. So the experiment took a hell of a long time. So the litter though were never exposed to sodium nitrite. They were only exposed through the what? Through the drinking water. The mother drank the water with the sodium nitrite. Then now the litter were born. And once the litter were born, sodium nitrite is off the scene. And then the litter were never really directly exposed to sodium nitrite. So those litter now, we kept them till they became adult rats. And they developed a lot of breast cancer. Wow, maybe like 80% of them. And we had a control group, and those never developed any. Together with a whole heap of other kind of tumors. Right? But what's happened is that, so anytime you eat all those red sausages, you see the red sausages and all those kind of things, they have sodium nitrite. What is the leading cause of death? What is the leading cause of death in women? Breast cancer. Right? So breast cancer. Now, I have a little young lady here, Rachel here, and Chinese love to eat some special red sausage for Christmas. that is filled with sodium nitrite. Right. So ham, you see when you love your nice ham at Christmas, I'm afraid you're having a whole bag of sodium nitrite. Right. Okay. So but very interesting. But you will never believe that all kind of JP, all sort of different type of cancers and all that. So we linked up with Professor Escoffrey. One second was the head of pathology, and then now he said that what he thought that the sodium nitrate was produced what they call an oncogene. Right? So I've never heard that, when I was doing that, I never even heard of the term oncogene. It was then a hot word to use. Right? Oncogene, very good. So that's what we think it is. Anyway, let's just listen to the story. So we've presented this thing, it's going for the 100th Congress of the Anatomical Association of America in Washington. And getting everything and producing everything on the poster and all sort of things. Then Prof. C was leaving the very next morning. So working late in the apartment in the night. And I'm hungry as ever. So I have a little tin of Vienna sausages, blam. Hold on, what is in this tin? When I look, full of sodium nitrite. Alright? But very interesting. So very interesting about, well, I'd eaten it already this afternoon.
Do you still eat it?
No, so I have cut out a lot of sodium nitrite, reasonable, and I tell all the females in my family that they must beware of it. Okay, so leave it alone. But I think just now in the States, they're starting to ban it. Now let's look at some sections, alright? So I had to tell you, because you're ladies, reasonable, and for your health, right? So stay away from sodium nitrite. Alright, let's look at it right here now. So this section here, very good. There you see the anterior limb of the internal capsule clear. This has a bit of the what? A bit of the globus pallidus. You see a little of it starting to appear? Right? This is what part of the caudate nucleus are we looking at? The head. That's the head of the caudate nucleus. Reasonable? So Professor Lebut is going to talk to you about all the afferents and efferents from the caudate nucleus. Reasonable? There we see now the external capsule, which will have a lot of the corticostriate fibers descending in it. The extreme is not seen here. There we see the anterior commissure. And just behind the anterior commissure, who is this big fella right here? The anterior column of the fornix. Reasonable? So that's the anterior commissure. Okay? So this area is very, very, very important. That's the area of the nucleus accumbens. So this area is very, very, very important. Okay? So there we see now the area of the amygdala, which would be right about here. Reasonable? And there we see the optochiasma right here. That's a little infundibulum stalk right here. Okay? Very good. Alright, so we have looked at this section. So let's take some, let's say some arbitrary sections. Anything we can look at. Okay? Now, there's one that is very interesting. This one. Is it this one? I hope I brought the one that I really like a lot. There's one that when you turn it one way, you see the level of the superior colliculus, and the other you see the level of the inferior colliculus. Give a chance. Beautiful, here it is. Very good. All right, so this is a fantastic specimen. Beautiful, right? And here we're looking at, so it's right on. Right on. Excellent. Very good. All right. Okay. So who is this? So we're looking at a section that is going from forebrain through to midbrain, then into what? Pons. Reasonable? So we come right up here. Okay, so we see the corpus callosum. We see this bird-like structure, the crura of the fornix. Then we see this structure back here, looking very much the pulvinar of the thalamus. Okay, that's the pulvinar of the thalamus. Main connections of the pulvinar of the thalamus, MGB and LGB. Reasonable? And the association cortices. Reasonable? Alright. So there's the pulvinar of the thalamus right here. Then we see this sort of, you see why they named it like that? It's sort of like having some bands in it. Right? So that is the stria terminalis. Okay? And you can see this exam pinose placed right here. Betty, see the exam pinose placed right there. Alright, and that is the what? Body of the caudate nucleus. Reasonable? So that's the body of the caudate nucleus. And there we can see the what? The stria terminalis. Okay? And there we see now the pulvinar of the thalamus. Okay? Alright? We can see now the hippocampus covered by the alveolus. Then we see this area here which is called the what? Subiculum. And then feeding into the parahippocampal gyrus. There you can see the aqueductus sylvius. Reasonable? You can see the substantia nigra right here. Okay? Right there is substantia nigra. Okay, which has, and then this part will be a bit of the crus cerebri. But this is the important boy. And that is the decussation of the superior cerebellar peduncle. Reasonable? So the main output of the cerebellum is through the superior cerebellar peduncle. The main output is coming through the superior cerebellar peduncle, and everything coming out through the superior cerebellar peduncle crosses in the decussation of the superior cerebellar peduncle. Heading to what structure? The red nucleus. Reasonable? Where it's going to envelop the red nucleus. Some fibers will end in the red nucleus, other fibers will just envelop it like a halo to proceed onwards. Reasonable? Alright. And then here we can see the pons. Okay, so this is a nice section. When we turn it over on this side, this is already red. Let me hold it like this. Because the color is coming off from my hand. Okay, so alright. So when we turn it over here now, we see that more at the level of the superior colliculus, isn't that so? Alright. Alright. Who is this boy right here? Who is that fellow right here? And that is the optic tract. Reasonable? That boy up there in that little corner is the optic tract. Reasonable? Okay, so he's going to come around, and he's supplied by which artery? The anterior choroidal artery. Reasonable? This is a beautiful specimen, so maybe this person might have had Parkinson's. Because what we see is that it's very, very depleted here, not much at all. Still there's something, but not very what? Very dark. And there we can clearly see the difference between the pars compacta and the pars reticulata. Okay? And then we can see the what? The crus cerebri. And this is beautiful. You can actually see the tract fibers. You can see them how they're all bundled up. You see all the bundles in the crus cerebri?
Yeah.
Right. Look at this. This is so beautiful. You can actually see all the little bundles that are there. Okay? Some being in the middle part being the what? The corticospinal and corticobulbar. And very important as the frontopontine right here. Okay? Then you see now as you see in this specimen here now, you really don't see much of a what? A collateral eminence. Right? So you're not always going to see the collateral eminence at all. Okay? You're not going to always see the collateral eminence. Okay? Alright. So that's a very good section. Alright. Okay. Okay. Here. Where's that one? What is that? Oh, very good. Okay. Ah, very good. So, very good. So you're looking back here now at the what? The very posterior end of the what? The hippocampus. And then we can see the what? The alveolus, which is going to give rise to the fibria and the just leaving. Then we see the what? The splenium of the corpus callosum. And you can see now very nicely the corpora quadrigemini right here with the superior colliculi and inferior colliculi, right? And then that's inferior colliculus here. This is the frenulum villi. Then who do you think this structure is coming up along here? So leading up to the side here. So leading up to it is the lateral lemniscus, right? The lateral lemniscus. It makes a band on the side of the midbrain coming up, and that is the just coming up, ascending up with the lateral lemniscus, which is going to end in the what? The inferior colliculus. The lateral lemniscus connects what to what? Connects the superior olivary nucleus to the inferior colliculus. The superior olivary nucleus to the inferior colliculus. Okay? Alright. So I think you are not bad. We've looked at enough sections. Reasonable? Right? I think that we're alright. Okay, let's move on now to thalamus. Alright, before we move on to thalamus, let's look back over here. Well, leave that for now. Alright, so we look at thalamus now. So, well, before we look at, let's look at thalamus, as we say, on the specimen first. Okay? So before we go and draw there, now let us look at the thalamus on the specimen itself. Okay. Let me drink some. Alright, so the thalamus. Well, my real topic is the diencephalon. Reasonable? Why is it this color? You think I'm drinking some coffee water now? No. I put a little honey in it. Good for your health and your complexion. There we go. It was GP that gave me the secret. Very good. All right. All right. So we are moving now to the thalamus. Reasonable? So the thalamus. So we are really doing diencephalon, but already we have spent a long time, a whole heap of time on in endocrine is hypothalamus. So you really know the hypothalamus inside out. That was the whole core of endocrine system. Reasonable? All right. The whole core of, and you know, wow, I can't tell you the whole thing, but we have a beautiful research project which is going to be submitted for publication soon, came out of the hypothalamus. Very good, because the patient had hypophagia and aggressive behavior. Which nucleus of the hypothalamus you think might be affected? Hypophagia and aggressive. Was born, little baby was born and growing up very aggressive and a lot of wanting to eat.
Ventromedial.
Yes. The what?
Ventromedial.
She's hot. Very good. So the ventromedial nucleus. Excellent. Shamara is very good, you know. Very good. So we know a lot about the hypothalamus, reasonable. We know a lot about the pineal, reasonable. Which is the pineal is going to what? The pineal is what? Going to be what? Regulating onset of puberty. So that person also had CPP, central precocious puberty. So the baby born also like very mature with breasts. So, reasonable. And ovaries and all, the ovaries well developed and all sort of other. So CPP, central what? Precocious puberty. Alright. So there, so pineal gland is going to regulate what? Onset of puberty. So there we see now the thalamus. Alright. There you see the pulvinar of the thalamus right here. And the pulvinar thalamus is going to overhang LGB and MGB, right? So just a little, let me one of your, just, yeah, just a shimmer right there, that's it. So very interesting right here. So, right, so when we look at the pulvinar, when we look at the pulvinar of the thalamus, reasonable, the pulvinar of the thalamus, you're going to get LGB, you're going to get MGBs here, then at a lower level here we're going to get, using a different color, we're going to get superior colliculi and what? Inferior colliculi. Reason so I'm looking from the back of the brain. I'm looking posteriorly, like under there. So the corpus callosum, the splenium, these are going to be a big structure up here. So this is pulvinar of the thalamus. Reasonable? So what is happening is that the optic tract is coming back around, and the optic tract is going to end primarily in what? In LGB, right? But some of those fibers are going to continue onward, not synapse in LGB, and skirt under the pulvinar of the thalamus, and feed in directly to what? To the superior colliculus. And this structure is called the what? The superior brachium. Okay? So it's variably developed. That's the superior brachium. Okay? Alright? And then we are going to find the inferior brachium, which is going to connect the inferior colliculus to what? To the MGB. Right? So this is MGB. So we have two things that we need to be concerned about. Pulvinar thalamus, just below it, skirting below it is the what? The superior brachium. Reasonable? Then we have the colliculi, and then we have connecting, this will be the what? The MGB. Then coming off on the side, which I was trying to show you now, this will be the lateral meniscus. Reasonable? Alright? So this area is very, very important. Very good. So that's the superior brachium, and this is called inferior brachium. Okay. Alright. Very good. So the thalamus, okay, the thalamus, just relax. Thalamus is very, very important. It is what? The relay station. The sensory relay station. So other than smell, which will go directly to the cortex, everybody has to do business with the thalamus. It is a relay station. Reasonable? Alright? So you see back here now, it has, it's like an egg. And you can see that laterally there is related to the, we see overhanging it here is the what? The body of the caudate nucleus. There you can see the head, and there you can see the anterior end. Anterior end is in relation to the foramen of Monroe. Right? So it's an egg. It's an egg here, and it has an anterior end, which is in relation to the foramen of Monroe, and a posterior end, which is forming this pillow-like structure known as the pulvinar. It has a superior surface related to a number of things. It has a medial surface, which is now in relation to the what? The third ventricle, covered by the ependymon of the third ventricle, and having the massa intermedia, separated from the hypothalamus by this groove. And that groove is called the hypothalamic sulcus. So inferiorly we have hypothalamus and subthalamus. Right? The subthalamus is a very, very important area, and Professor Putin is going to say a lot about the subthalamus, right? Because in basal ganglia, those nuclei in the subthalamus are very important. Okay? So there you see going to the subthalamus. Now we see traveling along the medial aspect, this band, and that band is called the what? Striomedularis thalami, which is going to end in the habenular nucleus. Striomedularis thalami connects what to what? The septal area to the habenular nucleus. Reasonable? And remember, one of the major outputs from the habenular nucleus is something called the fasciculus retroflexus to the interpeduncular nucleus. Reasonable? Alright? So let's now do, and we see lateral to the thalamus, right here. Lateral to the thalamus is what? The internal capsule. Isn't that so? Lateral to the thalamus is the internal capsule. Alright, so let's draw a diagram of it. Alright. So we had a lecture. Alright. Shamara, just. So I need paper. No, I need a bigger paper. Why do I need a bigger paper? Because it's in connections. Reasonable? Alright, so here we go. Alright, so we're going to take a section of the thalamus, a horizontal section of the thalamus. The long axis of the thalamus is which way? Like this. Reasonable? The long axis goes along like that. Reasonable? Very good. So the thalamus is like this. Reasonable? It's in shape. It has an oblique axis which is facing what? We see more medially. Isn't that so? So there is the outline of the thalamus right here. Okay. Alright. No, it's divided into three main what do you call moieties? Alright, three main moieties by the what? By the internal medullary lamina. Now, affixed to the back of the thalamus are the medial geniculate body and the lateral geniculate body. So affixed to it at the back is the medial geniculate body and the lateral geniculate bodies. Okay? So right back here, we find medial geniculate, which was once known as the metathalamus. Okay? So back here we get, this is more medial here, so this is MGB. And back here that is LGB. This is going to be connected in the midline with the other thalamus. Reasonable? So in the midline there is what's called a massa intermedia. Okay? And then traveling, as we said, along here, this is going to be the what? Stria medullaris thalamic. Reasonable? So just skirting along right here, this is the stria medullaris thalamic. Okay? Very good. Going back to the what? To the habitual nucleus. No, it has in it what is referred to as the internal medullary lamina. And that internal medullary lamina comes like this. And then will divide. Reasonable? It's going to divide. Okay? So this is the internal medullary lamina. Similarly, outside on the lateral side here is an external medullary lamina. Okay, so outside here we get another layer, and that is the external medullary lamina. What structure occurs, Shamara, what structure occurs lateral to the external medullary lamina? The reticular nucleus. Reasonable? So the reticular nucleus of the thalamus is as a lateral relation. Okay? And further lateral to that is what? The lenticulothalamic part of the internal capsule. So around here, so around here, this is the what? The lenticulothalamic part of the internal capsule. Reasonable? But it's really bigger than that. It should be much broader. Okay. No. They have this, so these three moieties. This is the medial nucleus, this is the anterior nucleus, this is the lateral nucleus. In the internal medullary lamina, who do we find? Two important nuclei. What are the two important? They're intramedullary lamina, and these are the what? The centromedial and the parafascicular nuclei. Okay, the centromedial and the parafascicular nuclei. Okay. Now this is going to have a dorsal tear and a ventral tear. The ventral tear we can subdivide into what? Okay, so VA is right here. Then we have VP, right? So this is VA, this is VL, and then now VP subdivided into A VPN and a VPL.
I'm not taking you out.
Okay? Alright. I'm taking my time. This is VPN and VPL. Above this, we're going to have which nuclei? Above this, we're going to have, so this, say we're looking at a lateral view this way, right? We're looking at it laterally like that. Therefore, we're going to have dorsal lateral, dorsal what? Posterior and pulvinar. So this is going to be in the dorsal tear. What we have shown here is the what? The ventral tear. Reasonable? Where we have what? VA, VL, sorry, and VP. Reasonable? No. What basically are the connections of VL? So VL is going to receive what? VL receives what? So VPL, sorry. So Dr. Brown, where's Akila? Is she here still? Akila, very good. What color is she in? Purple. Very good. So Akila, when we think of VPL, what is going to VPL now? Very good. Why like those answers? You see, you have to, Lennox, we have to what? Ask. You always, when you're teaching, you always presume that the student knows everything you know. All right. So VPL is going to be what? A synaptic. VPL, give a chance. VPL is what? A synaptic relay station for pain, temperature, touch, pressure, vibration sense. Everything coming with exception to the head. Reasonable? So everything that all the sensory input, reasonable, has to go through VPL. Okay? And we know that the dorsal columns eventually become the medial lemniscus. The anterior lateral system will become the what? The spinal column. Reason I mean the spinal lemniscus. So the two major inputs therefore will be what? Very important is the what? Two major inputs are the what? Medial lemniscus, but more important is the what? Spinal. So the spinal lemniscus is very important. That's an upward continuation of the spinal thalamic tracts. Reasonable? But this spinal lemniscus, by the way, when it comes up, especially the pain fibers, a lot of them are also going to go into what? Central medial and the parafascicular nuclei. Reasonable? A lot of them will feed into there. And remember, as the spinal lemniscus is ascending the brainstem, it is giving off important input to what? To the raphe nucleus, to the what? To the reticular formation. Okay, so very important is to the reticular formation. Reasonable? But very important is the spinal lemniscus. So pain can be felt. They say pain can be felt at the thalamic level, right? But for quantitative and qualitative assessment, it is now sent on to the post-central gyrus, right? So from here now we're going to get the projection, and that projection we know is going to go via what? The internal capsule, corona radiata, to where? To the post-central gyrus. Reasonable? The body is inverted. Okay? Now, in some centers in the world, where there is intractable pain, right, and the pain is there and the patient is like a terminal patient, they can quickly do a stereotaxic technique and burn that nucleus. Reasonable? And abolish a lot of the pain. Reasonable? So like, in England, in all these places, say for Parkinson's disease and all that, they're using what is called deep brain stimulation, where they're putting electrodes into various parts of the brain. It's like you have a pacemaker here to stimulate those areas. But similar to that area can be burnt out. Reasonable? So that's VPL. That's receiving the spinal lemniscus and what else? and the medial lemniscus. So spider lemniscus and medial lemniscus. That's going to be darker green. Okay, so Aquila, we understand that now? Very good. Very good. So remember, there is something, as I was coming here today to give my little class, what was I thinking of? That we set a lot in the exam. Dermatomes. What am I thinking of? Dermatomes. Right? Chief, were you thinking of dermatomes when you were coming today?
Not at all.
No. What was he thinking about? At 23 years or so, what is he, or 18 or 19, what is he thinking about? I wonder if I'll buck up so and so. Right? So his mind is more orientated to those kind of things. Reasonable? Alright. Alright. So at our age now we're thinking about what? Dermatomes. Reasonable? So dermatomes is very, very important. Okay? So remember, there's a dermatomal mapakila, right? So you may be coming from the sole of the foot, which is what dermatome?
S1.
S1, reasonable. Or you may be coming from some part of the body, the umbilicus, D10, right? Or wherever, tip of the shoulder,
C4.
right? Reasonable. So you may be coming from any of these dermatomes. And then now remember, the cell body for the first order neuron is located where? Dorsal root ganglion has a central process and a peripheral process. Central process does what? Crosses. So pain, temperature, crude touch and pressure to ascend in the contralateral anterolateral system. But as it is passing through the grey horn, especially pain, it does business with what? Substantia gelatinosa, where we get gating. What is it? What pathway will descend to gate it? The reticulospinal, right? The reticulospinal play a very important role. Okay? Very good. So then we're going to ascend up, and then anterolateral system or spinothalamic, as it enters the medulla, changes its name and becomes what? Spinal lemniscus. Ascends through the tegmentum of the pons, reasonable? Okay, tegmentum of the midbrain to end in VPM. Okay? Now to VPM. Who goes to VPM? So from the head, reasonable? From the spine, from the sensory nucleus of the trigeminal nerve. So very important is the trigeminothalamic part. Okay, and then carrying visceral input will be what? Solitario thalamic. Reasonable? Alright, so solitario thalamic and trigeminothalamic. Okay, so that is going to go to, yes. Okay, what about VL? Remember that all of this input has, as it comes in, is going to have to filter through the what? Through the reticular nucleus. Okay? So what goes to VL? What's the main input? So the main input to VL will be what? What's the main input to VL? And this is the dentatothalamic tract. Reasonable? So the main input is the dentatothalamic tract.
Oh, there you go.
Okay, very, very important. Okay, the dentatothalamic. Okay. Okay. The dentatothalamic. What else is going to make an input into it? The red nucleus. What is your name, Shamar? What is this young lady here in the striped top?
What's your name? Jesus!
No, Shamar, you really don't know her name?
Natasha.
And she sits beside you every day? Very good.
I just know her.
So that's Natasha. So Natasha, what is that tract called? That's known as the what? The what?
Yeah.
The what? The
Red nucleus.
rubothalamic. Right?
Okay. That's not so.
Also, it is said that the interpose and the globose send a minor contribution to it. Reasonable? So via an interposed thalamic pathway, but very, very, I'm not even putting it down because it's not universal, not all the books will say. So I'm just leaving that out. So mainly it is from the dentate.
Alright.
Right. Now, this is going to go together with VA. But let's leave that alone. Where is this going to project to? Where is that projecting to? All right, so this is going to go into this is going to go into what? The genu of the internal capsule, corona radiata, to go to where? To go to primary motor, so motor, premotor, and supplementary motor cortices, right? Good. No, VA. What about VA? What about VA? So, a big structure called the lenticular fasciculus. Isn't that so? There's something called the lenticular fasciculus coming from the lentiform nucleus. Reasonable? Alright, so very important. And GP Prof. Lebanon is the Putin is going to talk about it. So very important is from the lenticular fasciculus. Reasonable? So that lenticular fasciculus goes through the internal capsule. Then there's a little structure that's related to it also called the ansa lenticularis. Right? The ansa lenticularis. And very important, it's also going to be getting input from the substantia nigra. So there's competing input, right? So the substantia nigra, so you talk about whether you have hypokinetic movements or hypokinetic movements. So these are nigrothalamic tracts. Okay? Alright. So all of these, and then we will go back to the same place back here again. Reasonable? So wherever VL is projecting to, VA will also project to. So Aquila, where VL is projecting to, we will also have VA and all these other students here. Is it Natasha?
Yes, sir.
Very good. That's a nice name. Very good. So all of these will feed so that we get what? Movement. No. Here we have made this nucleus very large. Maybe I made it a little too large. And that is the large dorsomedial. But before we get to that, let's deal with the anterior nucleus. What do we know about the anterior nucleus? Where is that getting its input from? Where is that getting its main input from? And that is really the relay station for the limbic system. So all of these are relay stations, and this one is relay for the what? The limbic system. Okay, so this is really getting the, what's the name of that tract? The mammillothalamic tract. Okay, named by after who? Vic Desert. Reasonable? The mammillothalamic tract now, Vic Desert. And that is going to go there. And from here, through the what? Anterior limb of the internal capsule to where? To the cingulate gyrus. Reasonable? And that will go to the good. Now the nucleus I am most interested in is this ball. Okay? So functionally, what is that anterior nucleus going to be associated with? What functions is the anterior nucleus associated with? Shamara, the anterior nucleus functionally, what is that associated with? Let me have some of this thing here. What is that associated with? You know, I cannot give you this what? Diagram. You know, I can't give it to you. I don't want to be scandalized. But it's a part of a calendar for Jerry and nephew. Very good.
Oh my gosh!
Very good.
That's it, sir. That's it. That's
When
right.
you say woke up the guys, even Dr. Ledekwe, who was asleep anymore. He was fast asleep while looking I'm here. Very good. Alright, so there we have yeah. Good. Alright. Let's get back over here. All right.
Superior and inferior collected.
So they say that this is much better than what's on this side. So if I gave any of the male students, they were not going to put it up this way, but they will put it up this way. Isn't that so easy? Very good. All right. See if this man is awake now. Look at him. He was fast asleep and dead. And Lord, will Mr. Gardner not finish? And look at him now. Well, I would say she has a beautiful figure. Wouldn't you say that? All right, leave it alone. All right. Let's get back to what. See, I woke up Dr. Lenenko. Look at him. He's awake now, right? Very good. All right. Okay, so now the medial, so the anterior nucleus of the thalamus, right? The anterior nucleus of the thalamus is related to what? Is related to what? The limbic system. See it here? This is limbic system. What is limbic system all about? Emotion. Reasonable? So this is a very limbic post now. Right? We are very limbic calendar.
That's emotion.
All right. I have a friend of mine, and when it comes to Christmas, he owns one of these big, to distribute rum and all that. I always ask him for one or two, some candles. But he gave me a couple, so I can spare one for one. Diagram. Very good. All right. So, the anterior nucleus is so important is what? Limbic function, which is very important in memory. What's important? Very important in what? Memory function. Right? So that's we have what's called the circle of Papez, and the circle of Papez will pass through the anterior nucleus. Okay? So that circle of Papez is very important. Okay? So that passes through the anterior nucleus. So memory function is very important, and all other limbic functions, right? So the whole sexual behavior is dependent on the limbic system. Reasonable? So the limbic system is for preservation of the individual and preservation of the species, right? And how do we preserve the species, Shamara? How do we preserve the species? We know about preservation of selfie. That's to drink some fluid and eat your food and protect yourself against anything. But how do you preservation of the species what? How do you preserve the species? And that to procreate. Yes, procreate. To what? To pass the genetic material into the next generation. So hardwired into the male's brain. Dr. Francis, hardwired into the male's brain. Right? We can't get over it, right? It is hardwired. Right? The wives try to disrupt all those wires, right? Pull out all the wires, right? But you can't, right? It's part of the male's nature. Is to what? To get genetic material into the next generation. That's just the way we were made, right? Our role in life is to what? Get material into the next generation. It's very important.
That's some of them.
So, right. And you heard Dr. Lenenko yesterday, right? Still very good. So it's very, very important. So that's limbic, reasonable, so very important. But it's really important that we know that in males you have to forgive them. You know, it's just what. Right? So we don't have maternal behavior and all the benefits, right? Or we're more programmed around a lot of way. Give a lot of trouble. Alright? So that is, and then also memory function. Reasonable? Memory is what? Very important. Okay, that is it. Now we come to the medial nucleus. So the medial nucleus we said is what? What's the function of the medial nucleus? So, Shamara, what's the function of the medial nucleus? What's the function of the medial nucleus? Right, so you girls know when you go to, the girls are always doing much better than the guys. So the girls, when they go to this library, they can what? Study. So my colleague here, beside me here, he's trying to study in the library. Then some beautiful young lady comes passing. Glamour, everything going on there. Isn't that true, yes or no? Yes, he says yes. Right? So it's a rough life for us, you know. So there. So this is the medial. This young lady doesn't like to hear that, you know. Is it? So the medial nucleus was the function of the medial nucleus. Medial nucleus is for what? For it is a sensory integrating center. What is it? Sensory integrating center. Integrating what? Somatosensory input and viscerosensory input, right? So it is a sensory integrating center. So what do we find? All other thalamic nuclei feed to this nucleus. So all other thalamic nuclei will feed into this nucleus. Reasonable? This nucleus also needs a major projection to the basal ganglia, right? So there are thalamostriate fibers, which these thalamostriate fibers are coming primarily from the medial nucleus, the centromedian and parafascicular. Those are thalamostriate. So the medial nucleus of the thalamus gets from all other thalamic nuclei. Reasonable? All other thalamic nuclei. Okay. It also gets from the what? From the hypothalamus. Reasonable? So from the hypothalamus there are some periventricular fibers, very important. There are some periventricular fibers, so it will also get an important contribution coming from the hypothalamus itself to what are called periventricular fibers, right? So from the hypothalamus. Now we know that the hypothalamus is getting main input from the what? From the limbic system, right? So the hypothalamus is very important with visceral type input, right? So this is going to be relayed into here. And then very important is the smell area. So the smell area of the brain, which Dr. Ledenko was talking about, the piriform cortex. That piriform cortex eventually now will feed into what? Will feed into the dorsomedial nucleus. So the dorsomedial nucleus is also going to get from the piriform area. And that's why smell is very important, right? So smell from the olfactory, from that piriform area. So that's from the olfactory cortex. And olfactory cortex will send a very important thing. So the subjective states of the individual are also, and very, especially in the animals that depend a lot on what? Scent. Okay? And especially now, that scent is very, very important. So you know you can be feeling grand and great, fantastic, and then you encounter a smell that is not a good story. How do you suddenly feel? Terrible. Yes or no, Shamara? Right. So smell can really even affect your subjective state, right? So the olfactory cortex, though it receives now the primary input, the olfactory cortex is going to send big input into the air. So the piriform area is also going to be feeding into this area, right? And the amygdala also will be sending input up to the dorsomedial nucleus, okay? But the dorsomedial nucleus is receiving from all other thalamic nuclei. It is the sensory integrating center. So two major functions about it, right? So it is the sensory integrating center for all somato and visceral sensory input. Reasonable? And then involved with the subjective states of the individual. All right? No. Shamara, you can see that this medial nucleus is receiving a lot. Okay? When this medial nucleus receives all of this now, what does it do business with now? Where is it doing its major business with? Right? And the major business is done with who, Natasha?
Cortex.
I want better than that. That's a dead story answer.
Prefrontal cortex.
Prefrontal cortex. Right, so the main connection is what? With the, and what's the type of connection? Reciprocal, right? So the main type also is the reciprocal connections. Reasonable? Through the what? Through the anterior limb of the internal capsule. Right? Sorry, this is will be going in both ways. Alright? So this is going to the prefrontal cortex. Reasonable? So the prefrontal cortex is very important. Okay? So that prefrontal cortex is very there. Okay? So subjective states and schizophrenia, for example, on the dorsolateral part of the prefrontal cortex, on the dorsolateral part of the prefrontal cortex, that's very associated with when there is problems there, right, with the cytoarchitecture, the connectivity of those neurons, and sometimes this is referred to as the nucleus of the schizophrenic. So the whole connection between the dorsomedial nucleus and the prefrontal dorsolateral part of the prefrontal cortex, very important. Reasonable? All right? So that's very, very important for the subjective states. All right? No. And then also, JP, what we're saying, something like the microglia, right? Remember the role of the microglia with the schizophrenia? That the microglia play an important role in that whole pathogenesis of schizophrenia. All right. I see you're wanting to go, but relax. Very good. You have to keep them here, right, Lena? All right. So let us get back to it. Give a chance. What's the blood supply to the thalamus? Last thing. What's the blood supply to the thalamus? Okay? All right. Blood supply to the thalamus. All right. What do we know about the blood supply? But if they give it to you and you scan and it's difficult to make a guard.
Sir, manalo pa na sir.
Okay. Very good. All right. No. Shamar is mental free.
Nicola usually does that.
Give a chance. All right. By the way, what's the name of the relations of the thalamus? What is the name of the layer that lies on the superior surface of the thalamus? Very good. There's a layer called the stratum what? Zonale. Reasonable? There is above is the ependymum. Superior relations would include from lateral to medial. Superior relations, MCQ, from lateral to medial. Body of the caudate nucleus, stria terminalis, thalamostriate veins, fornix, telocoroidea, and just at the border is stria terminalis thalamus, right? Stria medullaris thalamus. Okay. Blood supply is via what? Right down here, there is the what? Posterior perforated substance. So very important are the what? The what? The thalamoperforators. Reasonable? So very important are the thalamoperforators, which are coming from the posterior cerebral and posterior communicating. Posterior cerebral and posterior communicating. Then, from the posterior choroidal, from the posterior cerebral artery, also are thalamo-geniculate arteries. The thalamo-geniculate arteries, reasonable. And then lying on the top of it now is the choroid plexus. Reasonable? So also from the posterior choroidal artery. Right? So posterior choroidal artery. All of them primarily are from the posterior cerebral. End of story. That's okay? Or do you want to see more? You want to see more?